The next concept is stability. When we solve the roots of characteristic equation, if we plot the roots, if all the roots lie on left hand side of the plane, then we will say the system is stable. If one of the roots on right hand side, then the system is unstable. So if it lies on left hand side, the system is stable. So this is the concept of stability in time domain. Here there are again two concepts. One is absolute stability. Absolute stability is one which is stable for all variations in system parameter. So system parameter, we will call it as k. It is a constant which is a function of time or function of frequency. That means if the system is stable for all variations of system parameter, then we will say the system is absolutely stable. Another one is if it is varies only with limited system parameter, or it is stable for limited variations in system parameter, we will call it as marginal stability. So here it is stable for limited variations in system parameter. So this is a concept of marginal stability. In frequency response analysis, we will talk about relative stability. Relative stability is again comparison of absolute stability with other values. In the frequency response function, we will plot a graph or we will plot a frequency plot. From the frequency plot, the stability is compared with some reference specifications. That is nothing but relative stability. So these two stability are important. Here the roots of characteristic equation lies on left hand side for stable system. The roots of characteristic equation will lie on right hand side for unstable system. If the roots are in imaginary axis, then the system is neither stable nor unstable. This is a concept of stability. And in order to make feasible regarding this, a scientist called as Routh-Hurwitz, they proposed one criteria. In that criteria, they say if all the roots in first column of Routh array is strictly positive, then the system is stable. This is one of the concept of Routh-Hurwitz criterion. So initially they have taken a characteristic equation. Characteristic equation is 1 plus g of s h of s equal to 0. From this characteristic equation, they proposed a method, writing the characteristic equation in form of an array. That array is called as Routh array. Say for example, if the characteristic equation has a naught s to the power of 6 plus a1 s to the power of 5 plus a2 s to the power of 4 plus a3 s to the power of cube plus a2 s square plus a4 s square plus a5 s plus a6. So this is a characteristic equation. For the simplification, what I will write, this is a6, a5, a4, a3, a2, a1 and a0. So since to have a good differentiation between s powers and coefficients of corresponding terms, I will be using a6, a5 similar to power of s. It can be anything. Generally it will be a polynomial equation of n degree. So I have taken 6 degrees here. First what I have to consider is I have to draw a Routh array. In the Routh array, first I have to consider the highest power or highest degree polynomial. Here in the equation, the highest degree polynomial is s to the power of 6. So first I will write s to the power of 6. Then I have to write the coefficients. The first thing what I will do is I will write the coefficient of s to the power of 6. The coefficient of s to the power of 6 is a6. Next I will write next even coefficient. If it is having a odd degree, next odd, decreasing fashion. So it is having s to the power of 6. S to the power of 6 coefficient is a6. Then next decreasing even power is s to the power of 4. What is the coefficient of s to the power of 4? It is a4. Then next decreasing even coefficient, then a2, that is a coefficient of s square. Then next decreasing coefficient, it is constant, which is a0. Then similarly even power is completed. Next is odd, s to the power of 5. Again the coefficients you have to write. What is the coefficient of s to the power of 5? It is a5. What is the coefficient of next decreasing odd power? Next decreasing odd power is s cube. Coefficient of s cube is a3. Coefficient of s is a1. There is no term, you can leave dash. These two are referred to as Routh array . It is a basic Routh array. By keeping these two into consideration, the rest of the values we will be taking. If I write the next one is s to the power of 4, but from the characteristic equation, from the given characteristic equation, I will write only two things. If the given highest odd power, suppose if the characteristic equation is started with s to the power of 5, first I will write s to the power of 5, then s to the power of 4, that's all. First two arrays I have to write from the given question. Next I have to compute. What is this value? This value I will call it as b1, this value I will call it as b2, then b3, etc. So let us see what is b1. If it is a b1 is nothing but multiply the previous Routh array with the another previous Routh array. That means cross multiplication. a5, first when you computing b1, you have to consider the previous Routh array, a5 into a4 minus a6 into a3 divided by this a5. a5 I will consider as key element. So this is how we will calculate b1. Next b2. b2 is, leave this, a5 into a2 minus a6 into a1 divided by a5. So when I compute this into this divided by this, so that is nothing but it is b2. If I want to compute b3, first column of the Routh array I will be taking. So B3 A5 into A0 minus A6 into dash, dash is nothing but 0, A6 into 0 is 0 divided by the key element A5, so I will get A0 only, here I will get A0 from that value. So B3 is nothing but A0 and there is no term here dash, this B3 is nothing but A0. Next again the next array, that is S4 is completed. Next S3, this I will call it as E1, E2. Again, how to calculate E1? E1 is nothing but, take previous consideration, B1 into A3 minus A5 into B2 divided by B1. Here, while computing E1, the common thing is divided by B1 for all the elements. Next E2, again I will take E2 is nothing but the same, B1 into A1 minus A5 into B3, B1 into A1 minus A5 into B3 divided by B1. Next E3, yes, that is also possible. If I take E3, B1 into 0, this into 0 divided by this term will get vanishes. Then like this, similarly I have to calculate the next E1, that is S square, I will call it as F1, F2, then S to the power of 1, G1, then S to the power of 0. Up to this I have to compute until I will get the last term as a constant. According to Routh-Hurwitz criteria, it will say if the first column of Routh array has no change in the sign, that means from one column to other, from one row to other in the first column, one row to other, if there is no sign change, then the system is stable. If there is a sign change, the system is not stable. In other words, what it will say is, it is strictly positive. If all the numbers in the first columns are strictly positive, then it will be saying the system is stable. Otherwise, the system is unstable. Here, we can find out the two values. One is, what is the value of K? What is the value of system parameter? We can find out. And another one is, at what point it is crossing intersection. That means we can calculate the value of S. So these two things are possible when we use the characteristic equation. Obviously in the characteristic equation, if there are some roots, S square plus 2S plus 4 equal to 0, if we solve that, we need to get the values of S. This is one of the approach. When we want what is S, you take this equation, you will get the values. So this is about Routh-Hurwitz criterion, very important in order to determine the stability of the characteristic equation. So this Routh-Hurwitz criterion will give what is the absolute stability in the system. So here we are not calculating any relative stability, it is giving directly what is the absolute stability in the system. So in order to understand the procedures, we will solve some of the problems. There are three types of problems basically. The first type is all the elements will be strictly positive, we can easily solve. Second case is, if you get negative also you can solve in the first case. Second case is, you will get identical rows. If you get identical rows, the method for this is, you need to differentiate the previous equation, auxiliary equation, to a 0. You will get identical rows 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, or you may get 0, 0, 0. If you get 0 in all the row, in one row, if you get 0, if all the elements in a row will be 0, if E1 is 0, E2 is 0, E3 is 0, then this is the second case. Then if you get first column 0, so suppose if you get F1 0, then how to compute? Is it stopped? No, we have to compute. Then introduce a dummy and then after that introducing dummy, I will call it that as M. M is a dummy element there. After that I will be equating M is equal to 0 and then you have to solve. So totally there are 3 cases of problem. So these 3 are the important cases while solving Routh-Hurwitz criterion. Let us solve some of the problems on RH criterion. So here I will take up the first case. The first case is none of the elements will be 0 in first column. So this is case 1. So first I will take problem number 1. Problem number 1 is determine stability using Routh-Hurwitz criterion. So here they can give any of the things. Either they can give open loop transfer function or closed loop transfer function, or just they can give a characteristic equation. Here the characteristic equation will be given. It will be s to the power of 4 plus 5s cube plus 20s square plus 40s plus 50 equal to 0. So this is the first problem. You need to solve whether the system is stable or not. Let us write a root array first, Routh array. The highest power is s to the power of 4. I will write s to the power of 4 here. Then I will start writing the coefficients of s to the power of 4. What are the coefficients of s to the power of 4? Here it is 1. Then the next decreasing power. What is the next decreasing power? Is s square. It is 20. Then next decreasing even power. Next decreasing even power is s to the power of 0. S to the power of 0 is 1. It is a constant. It is 50. Then s cube. Next power. X cube coefficient is 5. Next decreasing odd power. It is s 40. Then nothing will be there. This is the first given data. I have to write first 2 rows based on the characteristic equation given in the question. Let us calculate s to the power of square. The next thing, how to calculate? Multiply this 20 into 5 minus 40. I will write this, I will take it as B1 will be equal to 5 into 20 minus 40 into 1 divided by key element is 5. So 25 is 100. 100 minus 40 is 60. 60 by 5. What is 60 by 5? 60 by 5 is 12. So this is 12. Then the next term is, the first row is common. 5 into 50 minus 1 into 0. So 5 into 50 minus 1 into 0 divided by 5. So you will get 50 only. This is the second term. Then I need to compute s to the power of 1. S to the power of 1 is 12 into 40. This I will call it as C1. 12 into 40. So this is how it will go. minus 5 into 50 divided by 12. So when you compute this value will be equal to 19.167. Then this term is 0, leave that. Then s to the power of 0 is saying 19.167 into 50 minus 0 divided by 19.167, you will be left out with 50. So this value, so this is B1, this is B2, this is C1, D1 I will write here since it is a first problem. 19.167 into 50 minus 0 divided by 19.167. It will get cancels and you will get the value 50. So here you see, you observe the first column of the Routh array. Here all the elements in the first column of Routh array is strictly positive. Why strictly positive means? Other thing we can write no sign change. Hence the system is stable. You have to write the comment based on the sign change in first column of Routh array. First column, not a row. So this is about first problem. Then let us solve second problem. Second problem is s to the power of 4 plus 8s cube plus 18s square plus 16s plus 5 equal to 0. Same story. First I have to start with highest power. So s to the power of 4, coefficient of s to the power of 4 is 1. The next decreasing coefficient is s square, it is 18. The next decreasing coefficient is s to the power of 0, the coefficient is 5. Then s cube coefficient is 8. Then s to the power of 1 coefficient is 16. Then nothing. So this should be s to the power of 4, next decreasing even power s square, next decreasing even power s0. Here s cube, next decreasing even power s to the power of 1, negative will come, leave that. Then I have to compute. What is s square? So here the first element, I will call it as B1, 8 into 18 minus 16 divided by 8. So B1 will be 8 into 18 minus 1 into 16 divided by 8. The value of this will be around 16. Then the second element B2 will be 8 into 5 minus 1 into 0 divided by 8. So 40 minus 0 is 40, 40 by 8 is 5. So the next element is s to the power of 1. S to the power of 1, I will call it as C1. C1 will be 16 into 16 minus 8 into 5 divided by 16. So 256 minus 40 divided by 16, it looks around 13.5. Then this value 0, 0, 0. So neglect it. Next s to the power of 0, 13.5 into 5. 13.5 into 5 minus 0 divided by 13.5, and this is 5. So these are the elements of the Routh array. Again you observe the first column. The first column is, all the elements in the first column are strictly positive. Here also all the elements in the first columns are strictly positive. Write the same comments. All the elements in the first column array is strictly positive, hence the system is stable. So these are the basic problems. In the exam, this may ask for 6 marks. 6 to 10 marks they will ask. So these problems will have weightage for 6 marks. In the exam, when they ask to find out the value of k and s, that problem will be asked for 10 marks. Same step you can do in root locus, that is intersection of root loci on imaginary axis. The same step you can follow here. Next I will take number 3, another problem. Another problem is s cube plus s square plus 2s plus 24 equal to 0. This is a characteristic equation. Let us write s cube 1, next decreasing is s to the power of 1, 2. Then s square, the first coefficient of s square is 1, then s to the power of 0 is 24. Then if I solve s to the power of 1, 1 into 2, 2 minus 24 is minus 22 divided by 1, it is minus 22. Then this term, there is no that element, leave that. Then s to the power of 0, what is s to the power of 0 here? Minus 22 into minus 22 into 24 divided by 1 into 0 divided by minus 22. So the answer will be 24. So here you need to observe in the first column, there is a sign change. From S2 to S1 there is one sign change, it is positive to negative. Again from S1 to S0 there is another sign change, negative to positive. Hence since there is a sign change, how many times? 2 times, so twice in the first column of Routh array. Because of sign change, what happens? It is not strictly positive. That also you can write. Hence, the system is unstable. Since there is a sign change, it is not positive, or else you can write like this. Since in the first elements, one of them is negative, the system is unstable. That is also correct, but this is the right way. How many times sign changes, that is important, because we will calculate, we will ascertain the stability based on that also, how many times. So here we will try to adjust the error. So this is about the first type of problem, which is direct, which has only the values. Here you are not determining the value of k. Let us solve 2 more problems. So very important problem, problem number 4. Discuss stability using RH criterion for C of S divided by R of S will be equal to K divided by S into S square plus S plus 1 into S plus 4 plus K. Again you have to ascertain what is the stability, but in the problem directly they have given closed loop transfer function. Let us rewrite it again. Closed loop transfer function C by R will be equal to K divided by S into S square plus S plus 1 into S plus 4 plus K. So this is in the form of g of s divided by 1 plus g of s into h of s. Here what I need is, I need characteristic equation. So this is characteristic equation. Thus characteristic equation 1 plus g of s h of s equal to 0. Where is this characteristic equation? It is in the denominator. Take the denominator. S into, therefore, s into s square plus s plus 1 into s plus 4 plus k equal to 0. This is a characteristic equation. Multiply it. So I will multiply s into s plus 4 here. First I will multiply s plus 4 into this. These two I will get multiply. S into s cube plus s square plus s plus 4s square plus 4s plus 4 equal to 0. Then I will segregate s cube terms, along with I will multiply s. So this will become s to the power of 4, only one term has s cube, then s square 1 plus 4, it is 5 s square into s, it will be 5s cube plus s terms 1s 4s, 4 plus 1, again it is 5s into s, it is 5s square plus constant term. How many constant terms are there? Only one, it is 4. 4 into s plus there is another term which is k, which is not in the bracket. So plus k equal to 0. So here you need to find out the value of k also for the stable system. It is not asked in the question, but you have to, whenever there is a k, you have to find out the value of k. Let us write the Routh array, s to the power of 4, coefficients 1, then 5, then k. If there is a k term, I will be leaving some gap because the k terms will be occupied here. Then s cube term, it is 5, then s to the power of 1, 4 dash. Then I will write s square term. So it is 5 into 5, 25, 25 minus 4, it is 21, 21 divided by 5, it is 4.2. Then 4 into k, 5 into k minus 0 divided by 5, it is k only. Then I will compute s to the power of 1. 4.2 into 4, it is looks about 16.4 is 8, 16.8 minus 5k, 16.8 minus 5k divided by 4.2. As already I told, I need to leave some space for k because of this term only. Then this term 4.2 into 0, this will not exist. Then s to the power of 0, what is s to the power of 0? This into k minus 4.2 into 0 is 0, divided by this term will get cancels. Directly I will get k. So let us solve the value of k here and also observe the sign change. Here there is no sign change. That sign change depends upon the value of k. So let us write what is the k, how to find out the value of k. Here I will take s to the power of 1 coefficient. What is the value of this coefficient? This value will be equal to 0. I will equate. Then 16.8 minus 5k divided by 4.2 equal to 0. So if you equate this, I will get 16.8 minus 5k equal to 0. Then what is the value of k? K will be equal to 16.8 divided by 5. 5 ones are, 5 threes are. It looks around 3.36. So if the value of k is equal to 3.36, then this term will be 0. It is for marginally stable. So if the value of k is more than 3.36, then this term will be negative. The system tends to become unstable. Therefore, for stable system, even if you give the value 0, this will be positive only. For stable system, the value of k should be 0 to 3.36. If you give the value of k in between this, then this will be positive. That's why we will write for stable system, the value of k will be 0 to 3.36. So this is the problem with k. Let us solve one more problem, the same thing. Discuss stability using Routh-Hurwitz criterion. Again, I will take C of s R of s for closed loop transfer function C of s R of s k divided by s cube plus 18 s square plus 77 s plus k. This is a question I have taken. Let us solve the same thing. C of s by R of s will be equal to k divided by s cube plus 18 s square plus 77 s plus k. The denominator part you have to solve. The denominator part, so 1 plus g of s h of s. What is this? This term, this is denominator. So s cube plus 18 s square plus 77 s plus k equal to 0. Let us write the root array s cube 1. Since it is a k, I will give some space. 77, no s to the power of 0 term. Then s square, 18 and k. So what is s to the power of 1 term here? S to the power of 1 term, multiply this to 18 into 77 minus k divided by 18. And this term is 0 because there is no term here. Then the last one, s to the power of 0. S to the power of 0 is, directly you can write this term. Because this into this divided by this will get cancels, you will get k only, provided if this term is 0. Again, we need to know what is the value of k, how to find out value of k. Thus, 18 into 77 minus k divided by 18 equal to 0. So what is the value of k? K will be equal to 18 into 7, it is around 1386. So this is a value of k. Again, for stable system, if k is less than 1386, system is stable. Why system is stable? Because all the values in first column of Routh array is positive. You can write the comment like this also. If k is greater than 1386, system is unstable. Why it is unstable? It will become negative. That means there will be sign change in first column of Routh array. Then if k is equal to 1386, it is marginally stable because some values will be lie on neither real axis nor imaginary axis. It will be on imaginary axis only. So neither imaginary nor real. That's why it is marginally stable. For the answer, I have to write this. This is the answer because I have to write always for stable system. That is a work for engineers. And again here they can ask any of the problem. The procedure remains same. Here the first case what we have solved in the first row, there are only non-zero term, non-zero elements. If non-zero elements are there, this rule is applicable. If there is any zero, second rule. Let us solve the second case. The case 2 is if there are zeros in a row, that means if one of the row is complete zero, then what we will do is we will call an auxiliary equation, and hence this rule is called as auxiliary polynomial. Let us see if the roots are like s cube, s square, s to the power of 1. If p, q, r are the given roots, m and n, p, q, r, m and n are the given roots. If you get 0 in a row, this is 0 in a row. How to solve this? So for this, you have to consider the previously solved equation. The previously solved equation is m and n. So define auxiliary equation. I will call it as AE. So what is auxiliary equation here? Auxiliary equation is previously solved one. So a square term. So m s square plus n equal to 0. Then after getting this, you differentiate this auxiliary equation and equate it to 0. After differentiating this, what you will get? So d by ds of ms square plus n equal to 0. Differentiation of s square is 2s into m. Differentiation of n is 0. So this is what you got. So next thing what you have to write is replace this zeros with these values, auxiliary values. Let us solve the problem, then you will be knowing how to solve it. After this, the steps will be like this. It is s cube, p, q, r, s square, m, n, s to the power of 1. What is s to the power of 1? Earlier it was 0. Now you take this replaced polynomial. So what is the coefficient of s here? S coefficient is 2m, here it is 0. Then you solve the next procedure. So this is how we will be solving while considering auxiliary equation. Let us solve one more problem, which is problem number 6, which is having a 0 in the row. See, s to the power of 3, s to the power of 6, 14s5, 24s4, 84s cube, 60s square, 112s plus 48 equal to 0. Let us write the given equation. First I will write the coefficient of s to the power of 6. It is 3. Next decreasing power is s to the power of 4, 24. Next decreasing power is s square, which is 60. Next decreasing power is s to the power of 0, which is constant, 48. Then s to the power of 5. S to the power of 5 is first 14. Then next decreasing is 8 s cube, 84. Then next decreasing is s to the power of 1, 112. Next you have to solve for s to the power of 4. It is 14 into 24 minus 84 into 3. So this is the step. So you will get around 6. This is the value. Then the next second is 14 into 60 minus 3 into 112 divided by 14. That the value is 48. Then this into this minus 0 divided by 14. The value what you will get is 48. Sorry, this is 36 and this is 48. Then s cube. S cube is 6 into 84 minus 36 into 14 divided by 6. So you will get 0 here if you calculate. Then 36 into 6 into 112 minus 48 into 14 divided by 6, again 0. This is again 0. So here the row will be 0. So what to do for this? You take an auxiliary equation which is defined in the previous case. So auxiliary equation is this one, 6, here s to the power of 4 plus, what is the s here, power of s? First s to the power of 4, then this is coefficient of next decreasing s term. If it is s to the power of 4, next decreasing is s square, it is 36 s square plus constant 48 equal to 0. This is auxiliary equation. You differentiate this auxiliary equation with respect to x, s and equal to 0. So here if you do this, it will be 6 4s are 24 s cube plus 36 2s are 72 s plus 42. Differentiation will be 0. So this is the auxiliary equation. I will rewrite it again from s cube, it was becoming 0. So what I will do is, instead of 0, I will write this as a new row. So first I will write s square, s to the power of 4, s to the power of 4 is 6, 36, 48. Then I will write s cube is 24, 72 dash. Then compute s square. Similarly, s square is 24 into 36 minus 6 into 72 divided by 24. It forms to be around 18. And 24 into 48 minus 0 divided by 24. It will be 48. Then this value 18 into 72 minus 24 into 48. It will be around 6. And these values will be not there since both are 0. Sorry, this is 8. Then s to the power of 0. Do it in calculator. 8 into 48 minus this divided by 8. It is 48. So these are the values what you have got for the Routh array. Again, check the first column. Here, up to here it is positive. Here also it is positive. Since all the elements in first column are positive, the system is stable. This problem will be asked for 6 to 8 marks.